Morning again, guys. So this is the second question on modeling with differentiation. So I'm going to go through this question here. It's slightly different in some ways, but the process is still the same. So I'm going to read the question. As we read the question, we're going to take any of the key information and what formulas we're going to need to do this. So a cylindrical biscuit tin has a close-fitting lid which overlaps the tin by 1 centimeters as given by the diagram. The radii of the tin and lid are both x. The tin and lid are made from a thin sheet of metal of area 80 pi centimeters squared. So, and there's no wastage. So that tells us that the surface area of both the tin and the lid is 80 pi centimeters. So that means I'm going to have a formula because of this. I'm going to have a formula for surface area. Okay. Now, the other thing, and you'll notice as well, you got the surface area of both is equal to 80 pi. So that tells us that we're going to use this formula to rearrange to get a subject and substitute into the other formula we're going to make. Now, the other one is the volume of the tin is V. So this is going to be what we're going to substitute into. And if you have a look down, like at B, you'll notice use differentiation to find positive values for V, which is stationary, find a maximum value for V. So you can see that it's always done it in this way. You'll always get something with a constant, with a known value. So that's going to be how you can rearrange and substitute that into the other equation, which you'll be finding the maximum for. So let's look at surface area first. So surface area of this here isn't too bad. So if we look at surface area, we got a top and a bottom, which is just going to be pi r squared times 2. So that's going to be 2 pi r squared. Now, I'm not going to write r squared. I'm just going to write x because x is our radius in this case. So 2 pi x squared. So that is our top plus bottom of our 10. Plus, okay, what else do we have? So we've got the top and the bottom. This is open. We've now got to deal with, we've got a curved surface of the tin and a curved surface of the lid. So the lid's not too bad. The lid is just, so if you remember to do curved surface of a cylinder, it's just the circumference times the height. So it's just 2 pi r. So 2 pi radius, which is x in this case, times height, which is just 1. So I don't have to do anything there, plus the curved surface of the tin. So curved surface of the tin, well, that's just going to be 2 pi r again. So that's 2 pi x. And then whatever this height is. Okay, so whatever that height is, which we're just going to call h. There is our formula, and it tells us that's equal to 80 pi. Now I'm going to do some simplification in a moment, but first off, let's write our other formula. I'm going to write it down here. So we want to do volume. So volume of the cylinder is really easy. So it's a prism, or not a prism because it's a circular object, but it is a circle times the area of the circle times the height, okay, or the depth of the object, like a prism. So volume is equal to area of the bottom is just going to be pi r squared, pi x squared, times the depth, which is going to be our height in this case. Very easily done. That is it. Okay, volume of a cylinder, very easy. So let's come back over to our surface area. Now this is a little bit long, but what we can do straight away, the first thing I'm going to do is I'm actually going to get rid of some of the stuff we can. So they all have a pi, so we can divide everything by pi. Another thing you should notice is they are all divisible by 2. So let's just make that 4. Just gets rid of our numbers here, okay? So it makes it a little bit simpler to deal with. I'm going to go back to the red pen. So we've got x squared plus x xh is equal to 40. Okay, let's bring these terms to the other side. So you've got xh is equal to 40 minus x squared minus x, and therefore h is equal to 40 minus x squared minus x, all divided by x. Now I could simplify this and break this into fractions, but it's going to make it harder, and you'll see that in a moment. So now I have my h. I'm hoping a lot of you going, I know what to do. I'm going to substitute it straight into this one here. So then, therefore, the volume is going to be pi x squared, and then I'm going to substitute my value for h's, which is that expression on the right-hand side, which is 40 minus x squared minus x, all divided by x. Now, if we're going to expand, we don't need to, but if we have a look, it's multiplication. We've got x squared, and we divide it by x. They are going to cancel, leaving you with pi x times 40 minus x squared minus x. Okay, we are going to put it into this form with our exponents at the end, but the point being, we're going to expand it. The reason for it is that if it's just a constant out front, we could ignore it when we differentiate. So we've got pi, it's going to be 40x. I'm just going to swap these around, so it's going to be minus x squared minus x cubed. And that is exactly what we've got. That's 5 mark. That's exactly what we've got when we formed this equation. Okay. Now what I'm going to do next is I'm going to go to a new slide because now we've got this equation here. So we've got this equation. Given that x can vary, now it says all of this. This is all broken down, but all of this can be one question, which is find the maximum value of v. So to find the maximum value of v, we want to turn around and we want to find when x, the point that we get we have a stationary point. So we want to find out when dv dx is equal to 0, because that's going to give us a stationary point, okay, which will be a local minimum or local maximum. And then we want to find out, we want to do d squared v dx squared. Okay, so we're going to do double differentiation, double derivative, because we want to find out if it's a maximum, and we will go through that as well. Okay, so first thing we need to do is we need to differentiate. We can actually do this twice to make it easier. Okay, so v dash is going to be, now we're just going to differentiate for all of them. So we could just leave the pi up front, and we're going to okay, because it's just a constant. We're going to differentiate. So this is 1. So it's going to be 1 to the front, which leaves, that's going to be 40, because it'll be x to the 0 minus. So 2 comes to the front, so it'll be 2x. It'll be to the power of 1 minus. And the last one's going to go 3 to the front, which is 3, and it becomes x squared. Okay. While we're at it, might as well, we're going to do this, we're going to use this in a second, but might as well do this double derivative, because we'll need it later, which is going to be, so pi times, that disappears, so you're going to have minus 2, and that's going to be minus 6x. Now, something's really cool here. As long as your value of x, so as long as x is greater than 0, okay, or greater than or equal to 0, no, just greater than 0. So as long as x is greater than 0, what you've got here, not is greater than or equal to 0, you're going to have your double derivative is going to be less than 0, okay, because it's negative. Okay, so as long as your x is greater or equal to 0, your double derivative is going to be less than 0, which means that the gradient is always decreasing. So if I was to draw a graph, if it's always decreasing, no matter what stationary, there's only going to be one stationary point, and it is going to be a maximum. Okay, so no matter what stationary point I get, you're going to get a maximum. Really, really helpful. Okay, so that actually answers one part C, but let's go through and find out what that value will be. So we want to do when v dash equals 0, so we want 0 is equal to pi 40 minus 2x minus 3x squared. Well, that just goes, let's make all this positive, so let's times it all by -1. So you've got 0 is equal to 3x squared plus 2x minus 40. Some of you, I've shown you how to do factorization with techniques like this. So it's going to be 3x and x. If you think about it, if you have 4 times 10, okay, 3 times 4 is 12. Okay, so if this is 4, this is 10, you'll have a difference of 2, where this will be 12, so we want this to be positive, and that to be negative. Therefore, you have two solutions. You have 3x minus 10 equals 0, or x is equal to 10 on 3, or you have x plus 4 equals 0, so x equals negative 4. Can't have a negative value because we're of a dimension, so therefore your only answer is x is equal to 10 on 3. Okay. Last but not least, that's, by the way, we found that's B. We talked about C already. That means we just want to find a maximum value for V. We're just going to substitute it into our original formula. So we have V is equal to pi times, we've got 40 times x, which is 10 on 3, minus 10 on 3 squared, minus 10 on 3 cubed, which is going to be, okay, it's going to be 2300 pi divided by 27. Okay, centimeters cubed. Leave it like this. So you got pi, it's nice, it's exact value, so leave it in this form. Last question. Determine the percentage of the sheet metal used in the lid when V is a maximum. Okay, so that means that we just want to find out the amount of sheet metal here. Now, we had an expression, if you go back to the previous slide, we had an expression for the lid here, and it's just another circle. Okay, so that's what we're going to do. So we're just going to do, let's just do a new slide. Okay, so remember our x is equal to 10 on 3 centimeters when we have a volume as maximum. Therefore, let's find the surface area or the lid. So the area, the amount of sheet metal we need for the lid is going to be one circle up top, which is going to be pi times x squared plus distance around the outside, which is just 2 pi x. Substitute in your values for x here. That goes going to be pi times 10 on 3 squared plus 2 pi 10 on 3. Okay, that gives me, okay, once you've done that, 160 on 9 pi. Now we want to find percentage of the sheet metal used compared to the whole sheet metal. We want this divided by 80 pi. They cancel. They cancel. So you got 16 on 9 times 8 is 72. Okay, which is just, you divide both by 8. So you got 2 on 9, or that's 0.2 recurring, 22%. Okay. Hope this was helpful. Okay, I'll speak to you soon.